where we left off, right? We were talking about function, notation, and domain and range and all that good stuff. Here's where we left off. We were looking at a graph, and you guys were telling me what the domain and the range were. And remember how we did that, right? The domain is the set of all the x values that we could input into the function, or the relation. We don't know if it's a function yet, right? And it would correspond to all of the x coordinates that an ant walking on that graph could ever step on. The best way to think about it, or a really convenient way to think about it, is with those projections I was telling you guys about, right? So the domain, to get all the x values that are contained in the graph, we could just project the entire function onto the x-axis. Remember what that is. If we shine lights from above and below to create shadows, where would the shadows of the graph be on the x-axis? And you folks correctly told me that the shadow would start at -2 and end at +5, right? So the domain became x is greater than or equal to -2 and less than or equal to 5 if we wrote it using inequalities. And if we turn that into interval notation, well, then we just got brackets because we included the equal signs and the endpoints were closed. Remember how interval notation works. Left of the comma is the left endpoint of that one interval. I know it's one interval because I can put my pen down and draw it without ever taking my pen off the board. I only have to put my pen on the board one time to graph that domain, right? That segment. And to the right of the comma, the right endpoint of that interval ended up being 5. Okay, give me 1 to 5 on that. Is that ringing a bell? Is that all making sense? Let's do the same thing for range. Okay, how would I project this thing to graph the range? Where would I project it? Okay, good, onto the y-axis. So the lights are going to be on the side, and we're casting a shadow on the y-axis. Okay, so Isabel, if I cast a shadow of this thing onto the y-axis, where's the top of the shadow going to be? At what y value? Yeah, let me say it again. So we're shining lights from the side because we want to graph all of the y values contained in this graph. So that's going to, when I shine lights from the side onto this object, where is the top of the shadow going to be that it casts on the y-axis? What y value? So isn't this the top point right there, right? So if I cast a shadow of that top point onto the y-axis, so the light's out here, doesn't that just mean that the shadow's going to end up right there, right? And then the bottom, so the top is going to be up here at 4. Where's the bottom going to be? -2, right there. Exactly. And again, how come? Because there's the point and there's the shadow, right? And then everything in between, the rest of that graph would create a shadow that extends all the way from y equals -2 on the bottom to y equals +4 on the top, okay? So there's a graph of the range. How many intervals are contained in the range? Show me with your fingers. In the range, the green part. The answer is 1. How come? Because I can put my pen down one time and graph it, right? How would you ever have 2 intervals? Would that be like oars on a boat, right? Like if I had an oar statement and I had oars on a boat, I'd have to put my pen down once to draw the right oar, pick it off the board, and put it down a second time to create the second oar. So I have to put my pen on the board 2 times to create the 2 intervals. Everybody get that? Okay. How would I say that green range then using inequalities? Is that going to be an and or an or inequality if it's one segment? And, yeah. And what's the variable here, x or y? Y, good. So how do I say that then? Y is, if I have an and, it's got to be greater than the bottom and less than the top, right? Greater than, do I need an equal sign? I do, don't I? Yeah, because I'm including that endpoint. So y is greater than or equal to what value? -2, and less than or equal to, what's the top value? 4. Good. And if I write that with interval notation, that's easy to do. Just look at that interval, only now we're looking sideways. There's my comma. What's going to be the bottom boundary? Yeah, -2. What's the top boundary? Parentheses or brackets, everybody? Brackets, right? Because we're including the endpoints. We're including the equal signs in the endpoints, so we need brackets. Is this thing a function? No, it's not, because it violates what test? The vertical line test, yep. So it is not a function. Okay, so next, what about problems like this? So on these, like on the assignment, if you're given some equation like this, you're not going to be expected to know how to graph these yet. We haven't talked about any of that stuff. So what tool are you going to use to graph these? Desmos graphing, absolutely. So if we graph this thing with Desmos graphing, here's what we would get. Y equals -x squared plus 3. There's the graph, right? That's it. Okay, so what is that? That's just a parabola that goes down forever, and it looks like it has a top point. If I click on that point right there, I can see the top of the graph is at 3. Okay? So I'll tell you what, let's include a picture of this in the notes. How about? If you click on the graph, you can see that it wants to give you that top point, and there are the coordinates. Okay, so I'll put that on there for our notes. Okay, so if I graph this thing, then what did that look like? It just was it had a vertex, the top point was at 0, 3, and then it just did this, right? Then it just did something like that. Okay, so now, if I were to project that entire function onto the x-axis, where would the shadow be? I'll give you a hint. If I zoom out forever, would this thing ever stop growing? No. So what do you think, Gary? What would the projection of that entire infinite function be if I project the shadow onto the x-axis? The whole thing, yeah, right? And how come? Because of those arrows, right? This thing's going to keep spreading out as I zoom out forever. And so the projection onto the x-axis just looks like that. Well, that's all real numbers, isn't it? So the domain is all real numbers. How do I write that using interval notation? Yeah, -infinity to infinity with parentheses, because I can't include the endpoints. There aren't any. It just goes forever. What about the range? What would that projection look like if I shine lights from the sides and cast a shadow on the y-axis? So really all I'm doing is graphing all the y values in the function. Okay, so it's going to start there, and the shadow would just go down forever, wouldn't it? Right? So if I write that as an inequality, well, it's a range, so we're talking about y values. How do I say that as an inequality? Y is what? Less than or equal to 3. Yeah, because it just goes down forever. It never stops. So it's not an and inequality this time, because it's not a single interval. It just goes forever, right? So y is less than or equal to 3. And how would I say that with interval notation? Yeah, the bottom. So this time we have to turn our heads, right? We have to kind of turn our heads sideways to see this thing. The bottom y value is -infinity. The top y value is 3. So interval notation, it goes from -infinity to 3. What goes with the 3? A bracket or a parenthesis? A bracket, you bet, because I'm including the equal sign and I've got a closed endpoint. Is it a function? Does it pass the vertical line test? Yeah, it does. Okay, so now, real quick, what about something like, let's just do one of these. What about 14? Now, I can graph these on Desmos. What would happen? Do you remember what would happen if I graph the function x equals -1, or graph the relation? Okay, it's going to be a vertical line. That's what Desmos is going to tell me, where all the x values are -1. Okay, so it just looks like that. Okay, what's the domain? What's going to be the shadow of that function on the x-axis? It's a pretty small shadow. What is it? It's a single point at -1. Everybody agree? That's it. Shining a light from above and below just gives me this tiny shadow right there. That's it. So that's all it is. So what is the domain? X equals -1. How do I write that with interval notation? You can't. There's really no way to write it with interval notation. I guess you could, potentially you could write it like, but that doesn't really make any sense. I don't really need interval notation. All I have to do is just include set brackets with -1, because there's only one value. Okay? So that's a weird one. That's a weird one. What's the range going to be? All reals, because the projection of this thing onto the y-axis, yeah, it's obviously going to cover the entire y-axis. Again, how do I say that with interval notation? -infinity to infinity. Okay, so does the red vertical line pass the vertical line test? No. A vertical line is going to intersect that at an infinite number of places, isn't it? Right? So this one is definitely no. All right, so last issue for today. This is kind of a weird example, but it works. So functions, we're used to inputting x values and outputting y values, but you don't have to. We could input items on a menu and output prices. Still, that's a relation. It connects inputs to outputs. So first of all, look at A here. Is price a function of the item? Okay, think what that means. Is price a function of the item? That would be like saying price equals f of item. So what would the input be there, price or item? Item. When we say function of an item, we're saying function of the input, right? So the input is item and the output is price. So you guys give me thumbs. Look at that menu real quick. And first of all, remind me, what's the definition of a function? For each input, there is exactly one output. Okay, so is that true? For each input item, how many outputs are there? One. Yeah, if I input a jelly donut, the output is price. How many different prices are there for a jelly donut? One. No matter which of these donuts I input, the menu only outputs a single price. So is price a function of the item? Thumbs up or down? It is. Absolutely it is. It is, right? Because inputting an item always gives you exactly one output. So the answer is yes. Okay, what about part B? Is the item a function of the price? So if we flip that around, so f of price equals item. We're inputting price and outputting item. Okay, that is not a function. How come? What's the problem? What's the problem there? What input value causes problems? Yeah, if I input a price of $1.99, the problem is I'm outputting two different donuts, right? So this one is no. Okay, good? All right, go to work. You got the rest of the period to work on this assignment. It's up there.